Let's start by examining the data science code, and here we work on quantitative analysis. So we work both on supervised machine learning and unsupervised machine learning using this example here. And the example is related to exploring the word value surveys data. So these lines of code here, they literally just read in the data and show us the table of variable 10, which is the happiness of people. We can run it and we should see the results here. So here's the different number of values, and then so there's -1, 2, -2, -1, 1, 2, 3, 4, and then there's the number of people who have responded to each of these. So the data file is something like this. So here are the different values or variables defined, and then on each row there's one survey responder. So as we can see, the file is fairly long, but we don't actually want to check more on that data. And so on supervised machine learning, we want to predict something based on something else, and here we work on the variable 10. So we use this specific library called Carrot. You can access it more details on the documentation, and then Carrot is an R library meant for different kind of machine learning approaches, especially on supervised side of things. And then these lines here, this is where we split the data into training and test data sets. So remember that in supervised machine learning, we want to ensure that we only have or that we don't use all of the data to the model development. We want to have something to allow us to do the testing of said data as well. And here we can see that the idea is that we spend 70% for the training and then keep 30% as the testing data set. And here we literally just do the split of the data into two different data sets, training and testing data. Let's start running these. And then I just want to sort of show you that they still have all the values of all the variables in there. Here we do the model training. So we want to predict a variable 10 using variables 4, 5, 6, 7, 8, and 9. We use the training data, and then we use this specific method of doing this called AirPart, which is a decision tree approach. So we first need to train the model, which literally means that we take the training data and we start to fit it with the variables. And once we are ready, we can try to do a prediction. So we now have this model here, which is the same as the model there. We use that model to predict what kind of values we would get if we gave in the test dataset. So note that we actually give here we use the training dataset for building the model, and now we use this to predict values on data that the computer has not yet seen, and examining those findings. And here we can compare what's going on. So we can see that here are the predicted scores. So the machine learning system ended up predicting only values 1 and 2, because all of these are 0, which of course means that it's not that good machine learning model. And here are the sort of actual values. So from all the things where people actually responded for in the test data set, the machine learning system spent 605 into the class 2 and 160 into class 1. And then similarly, for things that had the value 1, it put 2463 into class 1, and then 630 6,313 into class 2. So it's absolutely not good. And then here we can see various kind of different measurements on the quality. Accuracy itself extremely poor, kappa value extremely poor. So this is not a good model. And this is how you can use this. So you always need to remember to do the test training split, and then you can define different kind of variables in here, and different kind of methods of doing that classification. Then you get some results as an outcome. And then here's a bunch of exercises, and we also want to show you how to do unsupervised machine learning. So in supervised machine learning, we tried to build a model that predicted V10 as well as possible. In unsupervised machine learning, we just want to sort of group the data based on its characteristics. And as the data is quite large, I'm just taking 500 items from that data set, and I'm trying to say that can you group them into 5 different kind of groups. And then this can quite easily. And then if we forget some of the warnings, what we do get is different variable values. So here are the 5 different kind of groups that were formed, and here are the average values for various kind of variables on the data set by those clusters. So for example, we can see that for variable 5 there is variance. So cluster 1 answered on average 2.2, whereas cluster 2 answered 1.9.